Hey, so I'm going to talk about what Eric sort of already alluded to a little bit, which is OpenAPI code generation for our Typescript SDK. So Eric touched on the fact that we have a bunch of cloud services, and each of them hosts their own OpenAPI spec. So in order to tailor my talk, I sort of assume no one has too much experience, but anyone who's used OpenAPI or Swagger before or read an OpenAPI Swagger spec? Nice. Oh, okay. So pretty good smattering. So I'm going to sort of sell you on the features, but like verbatim what OpenAPI, or what was formerly known as the Swagger 2.0 specification. So what it does is basically maps standard HTTP concepts into a standard specification where you can basically see how requests and responses are formed, and things like which operations are legal, and basically how to form your curl requests. So for us, so my team does we generate SDKs. So down at the bottom here, you can see we have SDKs in Go, TypeScript, and Python. So we're going to talk about TypeScript in detail later on, but basically starting from the top left, we have a bunch of services that are discoverable through a common gateway, which is for the Splunk Cloud service that we've been talking about. And so for each one of those specs, they have multiple versions that might be live at any given time. So you can see here I have a V2 Alpha 2 and a V2 Beta 1. These are all for the catalog service, which is sort of what organizes our metadata within the cloud platform. So we've got 3 different languages, soon to be 4. We've got about 11 different services. We have multiple versions per service. So you can imagine creating SDKs for that number of dimensions is totally unsustainable in a manual way. So what we've done is using a fork of a project called OpenAPI Generator, which is up top here. We basically have taken their ability to parse all of those OpenAPI like HTTP higher level constructs, and then had templates, in this case mustache templates, for each of the languages to sort of match the way that we have handcrafted and designed the SDKs using some business logic that makes sense for our platform, but mostly just like idiomatic approaches that make sense in Go and TypeScript and Python. And then, yeah, so we have basically an automated CI/CD pipeline where we have generated code at the end, and so we don't have to hand maintain these kinds of things. And so I guess what my sell for you is, maybe you don't have a platform that contains this amount of complexity, but like how many people are full stack developers that sort of either have a front end that interacts with the back end, or their own back ends that they write themselves? I bet that's going to be a lot of people here, right? Yeah, so imagine, let's say you wanted to do a design-driven approach, like you have an idea for a new endpoint or functionality that you want to test out, but let's say you wanted to start with the back-end implementation. If you had a pipeline like this, where you could actually just write a few lines of YAML or JSON, which is what OpenAPI is, you could basically say what you want to do. You'd have a client generated for you that would automatically be making requests to an endpoint that might not exist yet. You could either mock that endpoint, or you could sort of use that as your tester to sort of build out the back end and do debugging in that way. So that's a common workflow now that's sort of evolving as OpenAPI gets more mature. So I'm going to go over some high-level OpenAPI concepts. For those of you who are already familiar with these, bear with me a little bit, but it's basic. Like if you know HTTP, if you know curl, you know OpenAPI. So they have a concept of servers. So here I have like a sample curl command that's a real command that's hitting our ingest service. This is how we get events into the system. They could be structured or totally unstructured. So in this case, for those who can't see the screen, I'm just curling. I'm making a post to an endpoint that's called mytenant/ingest/v1 beta2/events. I'm just sending it some simple JSON that is an array of a single object that just has a property called body and a key value that's just the string hello. And so this is my request. I get a response that's also JSON. It's convenient that all of our endpoints almost entirely comprise of JSON payloads going in and out. OpenAPI plays really well with JSON, and this talk is about that. If you have other types of parameters or payload types, that's probably for a different talk, but most of us use JSON, right? So yeah, the concept up top of the highlighted red portion is just server. So where does the endpoint live? In this case, it's our API for our Splunk cloud services at api.scp.splunk.com. There's a concept of paths. So every endpoint that you would hope to hit, or for if you're developing a new API, in this case to ingest data, you just have a simple path. The one subtlety that I'll talk about in a second is you can also parameterize some of these paths. So for us, everything exists in a tenant namespace because we're a multi-tenant cloud stack. So the tenant will correspond to whatever the user's tenant is. We actually set that up in the client configuration. So up top, I'm making it to my tenant, but in OpenAPI, we have it parameterized as this tenant inside braces there. Then there's a concept of operations. So an operation is just a combination of a path and a method. So in this case, a post. So this operation is called post events, and we can use that to sort of define the things you can do in the system. So for an API client, it's like client.post events is something you would do if you wanted to ingest data. Finally, there's parameters. So I alluded to this earlier. So there's header, path, query parameters. There's a bunch of different ways that correspond to things you can do in HTTP. So in this case, we have an authorization header. That's how we sort of authenticate you with the system. It is a token that's generated that corresponds to a principal, like Tim in this case. We also have this parameterized path here, so that braces is then defined further on. So the name of that parameter is tenant, and it shows up in the path. Path parameters are always required because you can't form the path without them. And this type, it's just a string. So we have sort of a more complex pattern here to tell you what kind of header we're expecting in terms of that regex pattern down there. So that's pretty awesome in terms of being able to tell people exactly what format you expect. Here's a query parameter too. That's obviously super common. So here is a different endpoint. This is for actually getting search jobs, and so we just have a count here, which in this case is a number. And then finally, the real richness has to do with how to express how your payloads come in and out of the system. So in this case, for OpenAPI, we refer to those as schemas. The OpenAPI, actually I'll go into this in a bit, but in terms of what you're looking at in an OpenAPI spec file, you have this request body that shows you how the JSON is valid on the way in, and then this response for each type response code, in this case 200, we have, in this case, a different model of what that JSON payload looks like. So we're going to go into more details. And so what's common in OpenAPI specs is getting a little under the hood, but these things are called JSON pointers. It's just a way of like representing how to layer yourself inside. So you'll see that this event is actually, so this is like just a reference to another event that exists elsewhere inside the component schema nesting. So here's where that actual event is being described. So on a very high level, so the concept of OpenAPI schemas is borrowed entirely from JSON schemas. I don't know if anyone is familiar with that in particular. It does exist outside of OpenAPI. So it's a super rich way of describing what a JSON object, or basically any kind of payload you could have. So you could be really descriptive if you have a really weird endpoint that could take a string, or it could take a highly structured object. Like, it's all possible. Which is great in terms of ability to represent any kind of system, but it's really tough in terms of code generation, because a lot of those systems, like ultimately you're probably storing it in a model that makes sense in the back end, right? That's probably, maybe it has inheritance, or maybe it has ORM that maps to a database, but like the field of infinite possibilities is not something that's like necessarily great for wanting to generate a model for people to use inside your client, in this case, a TypeScript client, right? So our challenge is getting these into TypeScript models, and luckily, of the 3 languages that we support, so Go, Python, and TypeScript, TypeScript plays extremely well with JSON schemas, which makes sense, right? That's sort of JSON and JavaScript are obviously closely tied. And then, yeah, so here's what the specs that we receive are on the left. So this is an OpenAPI spec for a real service. What we've done is generate this model in TypeScript. So for events, so there's a few things going on here at once. So if we see at the 3rd line, the events defines a single required property, in this case, body. So if we see in our TypeScript model, we have attributes, host, and nanos. Those are all optional parameters with the little question mark there. Body is the only required parameter, and that's defined at top. You can see, so attributes, so actually the simpler ones first. So host and nanos down there. If you see in the spec, they're defined as type string and type integer and int32. In JavaScript, all numbers are floats, so we just define that as just a number, even though it's an integer. In strictly type Go language, obviously those have a lot more descriptive types that are strictly enforced. And then we start to get a little bit fancy here. I tried to sort of pick a medium case complexity. So if you look at the attributes property here of the event, so again, this is an event coming in. It's just JSON that we accept, and we use the body as sort of the information, and attributes, host, and nanos are sort of the metadata that relates to the event coming in. Attributes in this case, so we have it described as a type object with additional, so object means JSON objects, so we would start with braces. The additional properties subtlety here just means that it can have keys with values of any type. So you could also have additional properties, string, for example, and that would define the values of being strings, so keys of strings to values. So in attributes in TypeScript, you can see here we have key as a string because all JSON keys are strings, and then the value type is any. And so that's basically it. Body, in this case, has no type in OpenAPI, if you look on the left there. And what the way of handling that is if you specify no type, it could be basically any kind of JSON payload. So it could be a simple string. It could be a nested property of an object there. Anyway, getting really into the weeds now, but that's a very complicated way of saying I will accept the very simple case of body as a string hello, because I've given you the only required property there, and I've given it any kind of type on the right. So the response coming back, same kind of thing. This is a much simpler model. So it's just an object that has the code, details, and message properties. They're all optional in this case. So in the real world example, we can see that a code and message actually was given back in the end that says, hey, my event came in successfully. Getting a little bit more complicated, but I'm not going to go too far down this path. There's a new concept in OpenAPI 3 that didn't exist in Swagger 2 called OneUps. It's a way of sort of describing payloads. It makes sense for polymorphic sort of models where you have maybe some common fields. In this case, we have an action service, which is our way of triggering emails and webhooks depending on if your search results match certain criteria. So email and webhook actions, they're going to have, I don't have the schemas here in front of me, but they have common fields like title or ID, and then they have specific fields like for email, you have addresses you want to send to. For webhook, you have a webhook URL that you want to trigger. So this is a tricky model. It's not tricky, really, if you think of it as sort of inheritance the way we would normally write it if a human approached the problem. But in OpenAPI, we have this concept of OneUp, which is actually really sort of telling you to do type unions. So for TypeScript, they actually support type unions out of the box. It's one of the few languages that does. So those who don't know TypeScript super well, we basically define a new model that's an OR between email or webhook actions, which basically means you could see either one. And these have sort of fields in common, but also their own specific fields. Anyway, it's a way of saying it's really complicated in other languages, but it's actually super easy in TypeScript to understand it. So to put it all together, so here is the events API, and here's what our actual SDK looks like. So we define a function that we just use the operation ID to use. So it's just post events. You can see it takes that event array of events as the input. It gives you back a promise for an HTTP response. And all we need is the path. So this is all generated. So in our mustache templates, we basically define all of this logic. It's just taking the very easy to form sort of HTTP concepts and putting it in the form that our client expects that we sort of designed. So yeah, we're just performing a simple post here. Ever so slightly more complicated for that search job example with query parameters. So let's say you have a path parameter that you want to take as an input. So basically we have a search ID that the user gives us, and in this case we're using that to sort of form the URL on that end. So it's not much more complicated. So yeah, my main conclusion, I guess, is it might make sense for you to just, you can use the same project that we've been using, which is OpenAPI Generator, that's written in Java, but they have a bunch of different languages that they support, including many flavors of TypeScript. So take a look, that might work for you. And yeah, thanks for having me. That's it for me. That's a great question. So it's you don't. So it's sort of up to you to you could basically treat it as. So that's what we use in a lot of our tests. So we'll do like response action as email action, and then do a thing, and then sort of enforce it. So manually in our tests, I sort of glazed over this, but there's this concept of discriminators there. So what this is saying is this property kind will actually tell you which one maps to which. That's an OpenAPI concept. So in this case, literally the string email, that's what that mapping means, maps to the email action model, and webhook matches to the webhook action model. So you can sort of use that to manually sort of figure that out. We also have logic that I didn't show that basically does that for you. So, sorry, the question was, does OpenAPI have enough documentation for us? So, yeah, I think this is sort of a two-part. There's descriptions for every single field. So in terms of literally documenting it, you can basically describe every property of every model, of every endpoint, of every, and all of that maps to the sort of document generation scenario that Eric was talking about. But we also use it for code comments, right? Because you sort of get that for free. Like, what is the post events endpoint? Well, there's a description for that. But I think your real question is probably like, is it descriptive enough to make the right conclusions about like what your client should look like?
It's auto-generated documentation.
Yeah. I mean, we've been using it for like 8 months now, and automated documentation has been fantastic. You can also use it out of the box. Like Eric uses it with the Gatsby plugin to sort of make it have a look and feel and interaction the way we need it. But there's a project called Swagger UI that's kind of still alive, and you can just use that out of the box. So you don't have to write anything for yourself. So if you have a service that you own, or the back end of your sort of app that you're developing, you can, and we do this a lot, just plug it into Swagger UI. That'll show you exactly what kinds of responses they're making, and it'll actually let you try out requests to that in the browser. So yeah, it's been great for us. Yeah. So the question was about deprecation. Deprecation is sort of up to you. There's a concept of deprecation in OpenAPI, so you can mark it an operation as deprecated equals true, and then everything else is sort of up to you, right? So what do you want to do with that information? For TypeScript, would you want to log a warning in the console if it's ever called? I don't know. So they don't solve that for you, but they do give you the verbiage to tell people that it's deprecated, which is actually sort of the most important thing. Yeah. The question was how much customization we had to do on top of our library. So truest answer is we could have done almost nothing. We could have taken the client that gets generated automatically. They have, this project is a ton of people, and they have like sort of language-specific subteams that make it look and feel like idiomatic. Like the project is, the guts are written in Java, but they have these teams working on the templates. What we had was, we wanted to design the client ourselves for business logic that made sense for us. And so we already had a client, and we just wanted to make it look like ours. Actually, it didn't take much effort at all. It was really easy. So you basically start a new, the project's OpenAPI generator has a way of like easily scaffolding new languages. So in our case, we were building off of the Typescript client that already existed, but we just added our own templates, and they made that really easy. Honestly, it was a lot quicker than I ever thought. So it was really easy to customize.